Hi, this is Maggie. In this video we're going to talk about the command design pattern. If you haven't looked at the picture mover program, I recommend you watch that video and look at that code and then return here, as we will work with that program in this video. The command design pattern is one of the patterns described in the book published in 1995 called Design Patterns, written by the authors sometimes referred to as the Gang of Four. If you're planning on working as a software engineer, I recommend you read this book and any books you can find on using these patterns in the language or languages in which you develop. This association class diagram shows the objects, or you might think of them as object roles, in the command pattern. The object at the center is the command object, which represents an action within the system. It is created by, or it is a part of, the invoker, which is the originator of the command. In a graphical user interface, an invoker role is often taken by GUI controls such as buttons or menus. The other object in this pattern is the receiver. That is the object being acted on, the object that will change or react as a result of the command. So if the software is a spreadsheet, for example, the receiver might be a cell in the spreadsheet, or an entire sheet, or a chart, or a graph. This pattern decouples the invoker and the receiver of the command, which makes it easier to have multiple invokers attached to the same command. For example, if you had several different controls that perform the same function. Decoupling also makes it easier to change the command without affecting the invoker or receiver. The pattern encapsulates the information related to an action in the system in one object, the command object. Encapsulating the information in the command object facilitates undo and redo, including multiple undo and redo. It also makes it easier to replace or change the command. This sequence diagram shows a generic picture of the messages that are sent as part of this pattern. The invoker, remember that is something like a button or menu, receives some sort of action message. In response, it sends the execute message to its command. The command then sends whatever messages are necessary to the receiver in order to fulfill its responsibility. In our picture mover software, we currently have only one type of command. The user can move the picture by pressing the appropriate key. The picture mover class manages the event loop and directly interacts with the movable picture object, sending it a move message in response to a keystroke. If we implement the command pattern in this system, then the picture mover will become our invoker, or will take the invoker role. We will write a new command class called moveCommand, and the movable picture will be our receiver for a move command. What we'll do is add the abstract command superclass that is part of listing 6.5, and then we'll subclass it to create the moveCommand class. So I'll just copy-paste that in. The command class has one field, the executor, which is the receiver. That's the object that the command object will interact with to fulfill its responsibilities. For our moveCommand concrete subclass, the executor will be the movable picture object. And then we have init and execute. Init initializes the executor field from the parameter, and execute does nothing in the abstract superclass. Very simple. The command class does not know the invoker, and as I mentioned before, there could be multiple invokers invoking the same command. Now let's subclass this. We want to create a move command, so class move command, and in parentheses, command. And then we can change the comment to make it more accurate. Now I'm going to comment out the executor field, but I'll note that it's a movable picture object here. And we'll need to store the direction that the picture is moving in, which is an int, because it will be one of the direction constants from movable picture. Now just a note, there's another option here. We could have one move command object for each direction, or we can create a new move command every time the user presses an arrow key. If we have one move command object for each direction, so move up, move down, move left, move right, then that potentially uses less memory. But if we create a new move command for every move, then we can implement undo. And I think we might like to try that. So let's create a new move command each time the user presses a move key. So we're storing direction, and then in the init method we'll need to pass in the direction. And we'll initialize the superclass object. And pass up the executor. And then set the direction field. And in the execute method, we'll just send the move message to the executor, which is a movable picture. Okay, now we need to hook this into the invoker, which is the picture mover object. Down in the event loop, we'll need to create a move command object and send it the execute message if the user presses an appropriate key. So where we're sending the message here, we'll create a command. And we will initialize it at the top of the method. And reset it to none each time through the loop. I'll make that change for the rest of the directions. There, that's done. And when we run the program, works exactly as before. So this may seem like a lot of overhead for the same functionality. That is because this is such a simple program. If we were able to move a picture in multiple ways, or if we wanted to alter the way moving a picture works, we wouldn't have to change the picture mover class at all. We would change only the move command class, or we would add other invokers, other objects that create move command objects. The picture mover and the movable picture classes would be insulated from these changes. A huge benefit to the command pattern that is easy to see is the ability to undo a command. Let's create a list of commands, add our commands onto the list, and allow the user to undo as many commands as they want. We'll use the U key for undo. I will not create an undo command as in listing 6.6. If I do that, I'll have to distinguish between undoable commands and non-undoable commands, and I'd like to keep this a little simpler. You can see the more detailed example in the text. I'll just add handling the U key to the event loop. We could handle Control-Z, typically used for undo, but I don't want to get into another part of the event object. We'd need to look at the modifier keys. So we'll just handle a U for undo in this example. And we'll need to make a list of commands and append our commands to the list, which means the last added will be at the end. The last added will be the first undone. So we'll index in using the length of the list -1 after checking to see that there is at least one command in the list, and we'll send it the undo message. and then we'll take it off the list. I'd better go write that undo message. Okay, so up in command, we'll write an abstract undo message. And in move command, we'll have to write the concrete version. Now let's see. We have 0 is up, 1 is down, left is 2, and right is 3. I'm inclined to do this mathematically rather than logically, although using math means that we know something about how the directions are stored. So I don't think I'll use math, even though the logic is going to feel cumbersome. There are other options. We could change movable picture. We could add a move opposite method, or we could write a method that uses the math to return the opposite direction. But we can both leave movable picture alone and not pry into its implementation, even if it is public, and just use logic. Okay, so we'll write the logic. There. And before I run the program, note that I wrote an undo method for the move command, but I didn't change movable picture, and the only thing I did in the picture mover was set the program up to handle undo. Now that it's set up, I can add new commands if I want and undo them, and there will be no changes to any objects except to write the commands. So while this may seem like a lot of overhead, there's now a pattern in place to add undoable commands without changing the existing components of the system. Let's run the program now. And I'll press the up arrow and then U, and it moves back down. I can press right several times and then undo several times, but only once for each command. So that appears from this very limited demonstration to work. So that is the command pattern: invoker, command, and then receiver or executor. And that is how you can implement a multiple undo, and in a way that makes it easy to add new commands or new components that can invoke commands. I recommend that you practice with this, as with everything. Perhaps take the movable picture program and re-implement the command structure without referencing this video or the code unless you absolutely need to. You might also try implementing a settings command, a command that changes between the two different sets of keys as an enhancement and to practice this pattern. You might have to change the way the picture mover class works to implement this well, but as a bonus, you can check that our settings are changed when the document reopens from being pickled. Once you can implement the command pattern successfully, you're ready to move on.